Hello, everyone. Good evening, and thank you for joining us today for the final panel discussion of Sci-ROI India's virtual launch event 2022. This panel discussion, we will focus on understanding how mentored research at undergraduate level is important, and how early career researchers as well as students could benefit from undergraduate research. My name is Anushila Chatterjee, and I am the lead of program and curriculum design at Vikyanshala International. At Sci-ROI India, me and along with my team, we are developing and trying to implement an undergraduate research initiation program that aims to develop and inspire undergraduate students to take up research as a career. I'll introduce the program shortly, but before that, I would like to invite my colleague, Dr. Siva Sankari, to come and share with us why early career researchers are stakeholders for undergraduate research. Siva, up to you. On to you.
Yeah, hello everyone. Before we start the panel, I just want to introduce why we needed to have this session here. I have a little bit of experience when I was a lecturer in India for many undergraduates, and also here I've mentored many undergraduates during my PhD and postdoc, and so this comes with a teeny bit of personal experience as well. So usually I feel that undergraduate researchers bring in a lot of enthusiasm into the lab, because usually with the PhDs and postdocs, the lab becomes a little monotonous, and they bring in a lot of enthusiasm and fresh ideas into the lab. And they are great at networking. We usually don't discuss our small problems in experiments with person who is in a different discipline, but they usually network. They have a huge network, so they can discuss their problems and bring in troubleshooting ideas for any experiment. This has happened to me personally many times. And if you feel you're responsible for paying forward to bring to develop a good scientific society with good scientific temperament, then we need to invest at a very young age to foster this kind of scientific temperament to the undergraduate students. So that's an important feature for considering having undergraduate students in early career research laboratories. And also, if you want to try some small projects that your PhDs won't take up, then you can then give it to your undergraduates who doesn't have any preconceived bias towards experimentation. As we get older, we don't we have these notions that if I try this, then it might not work, things like that. But undergraduates are fresh and they are ready to take up risky projects, so we can try new ideas with them. And also nowadays, it is expected of PhD scholars and postdoc scholars to have some mentoring experience in addition to the usual scientific training that we have. So it's here. I'm talking here in US, it's important to have mentoring experiments for any kind of career advancement. And now in India also, according to this new national education policy, it is required that undergraduates should undergo some kind of training, and PhDs should undergo some kind of mentoring experience for their next career level. So this is with the early career researchers part. And like Anu said, when our team was discussing it, we realized the need for undergraduates to develop a kind of scientific temperament that puts them into research. So that is why, and we felt that all undergraduates are not equally equipped with this scientific temperament in order to get into the next level. So that is why we are trying to put together this program called REACT, and I'll leave it to Anu to take over to explain the program in detail.
Thank you, Siva. That gives me a smooth way to the upcoming slide. I present to you Sci-ROI India's REACT, or Research Activation Program, for building opportunities for the future STEM scientists. So REACT, it will be an online 6-month-long mentor research initiation program aimed to democratize access to research opportunities to undergraduates, especially undergraduates coming from institutes with limited research resources. The purpose of REACT is to develop a scientific mindset and provide capabilities to undergraduates to pursue research as a career. We will help them understand how research works and provide them with opportunities how research could be taken up as a career after they finish and continue. They can motivate them to take up higher studies and then pursue research. So who will be our target undergraduates? We are focusing on first and second year undergraduate students in STEM, so any science, technology, engineering, and mathematics fields. We will prioritize students who are coming from institutes that does not have extensive research opportunities. We do recognize that there is a huge gender gap in STEM fields, and we want to achieve a gender balanced cohort for REACT's program. And why do you think that undergraduates would benefit from participating in REACT? So we think that by participating in REACT, it will help them to understand how to think like a scientist, how science is conducted, or understand how knowledge is generated, and understand that they can be creators of knowledge rather than just consumers of knowledge. Gaining an understanding of research could also change their perspective on how to deal with challenges or failures, because I think research teaches you that challenges are just opportunities to ask new questions. You reformulate your hypothesis, you come up with alternate experiments and things like that. Of course, together, research gives you skills like 21st century skills such as critical thinking, problem solving, communication, collaboration. And since this is a mentored research program, the undergraduates will interact with the current scientists in training who can advise them about different careers in STEM, and probably not just research, and help them devise a plan for their steps after graduation. Now, going to mentors, who will be our mentors? We want to have senior PhD scholars and postdoctoral fellows who have an understanding of the Indian higher education system as our mentors. We are looking for individuals who are motivated and committed to give 6 months like commitment to the program, and they should be interested in doing interdisciplinary research, and preferably know at least one Indian language, just to reduce the language barrier in communication. The mentor-mentee ratio will be maximum of 4 mentees per mentor. And again, we want to, I think a lot of us have had questions like, should we have faculty as mentors, or should we have PhDs or postdocs as mentors? We thought PhDs and postdocs will benefit from gaining this mentoring experience because it will help them develop their identity as a scientist. It will help them understand what could be the possible roles and responsibilities of being a scientist, especially if you're going to academia. And when you are, as a PhD or postdoctoral student or a scholar, when you are explaining your research to an undergraduate, a fresh undergraduate, you would have to actually gain a deeper understanding of your own work and be able to explain that to an undergraduate. You would have to break it down. So improve your teaching communication skills. You'll develop an understanding of what skills you are good at, what are your interests, what are your shortcomings. And of course, that would give you a clarity on what career path you want to take beyond your PhD and postdoc. And together, these will enhance your CV because you'll be able to note these experiences in your CV. So just to give you a brief idea of what the program structure looks like, we'll have a core curriculum where all the mentees will attend these monthly webinars on topics related to research initiation by established researchers across the globe. And we'll have a mentor-led curriculum where mentees would learn, for example, how to read scientific literature, understand the process of scientific inquiry and scientific methodology, either using frugal techniques at home or some virtual lab techniques. And of course, they will, at the end of the program, they will have to communicate their scientific endeavors through oral as well as written communication. With that, I would like you to meet our team who has been working behind the scene, starting with our youngest member, Mr. Aniruddha Chattaraj. He is a graduate student at University of Connecticut. He's a coordinator at REACT. I am Anushila, and I am the lead coordinator of REACT. Manali, I don't think needs any more introduction. She is currently the Global STEM Operations Director and Coordinator of REACT. Without her, I don't think we would have reached where we are today. Not just the Sci-ROI virtual event, even for the REACT program. So thank you, Manali. Siva just talked before me. She is a postdoctoral researcher at MIT. And also a coordinator at REACT. And also looking to transition to faculty position soon. And finally, Dr. Sriram. Sriram is an associate professor at Azim Premji University and coordinator at REACT. And Sriram will be moderating the panel discussion that is coming up next. Sriram, would you like to start introducing our panel?
Thanks, Anushila. It's my pleasure and honor to introduce the panelists for today's discussion. So we have four panelists who are currently attending. Dr. Shiva Vasu is not currently available. Let me first introduce the person who I know the best, who is also my colleague, Jayant Vyasanekare. So Jayant is an assistant professor in physics at Azim Premji University, and he's interested broadly in celestial mechanics and quantum physics. Apart from what he's done in his research interests, one of the reasons why we have invited him is that he has been associated with what's called the Research REAP program, which is organized or at least conducted in the Bangalore Planetarium, whose aims are similar to the kind of program that we're aiming to start. But of course, it's held in the planetarium. It's not a virtual platform. Our second panelist is Dr. Kanika Sinha, who's joining us from IISER Pune. She's a mathematician whose interests are in number theory and various aspects of number theory. And she also has very extensive mentoring experience, has, of course, advised both masters and PhD theses, but also she's interested in broadly science communication, has written several articles in newspapers and journals for more lay audiences. And not until recently, she also used to, or maybe already she still does, used to write a quite popular blog which is of interest to a lot of people who are interested in coming back to Indian academia, called Academic Gardens. Our third panelist is Dr. Lakshmi Permalsamy, who is from Sri Ramachandra Institute of Higher Education and Research. She's interested in cellular signaling networks in cancer, and also brings with her extensive mentoring experience of undergraduate mentoring experience, including participating in the CSIR summer research training program in 2020. Our final panelist is Dr. Urmila Kulkarni-Kale. She's from the Savitribai Phule Pune University, and her specializes in bioinformatics and is one of the pioneers of bioinformatics in India. And again, a very distinguished career in bioinformatics, including helping out with setting up curricula and other processes in bioinformatics all over India, and has conducted several international workshops in this field. So I've tried to keep the introductions short so that we can have a more extensive discussion. So in terms of the format that we are going to do, at least this is what I would like to do. And of course, the panelists are free to interject as needed. But we have identified three themes which we feel are going to be most important for the audience. One is, of course, what is the importance of undergraduate research and mentoring? And then we would love for our panelists to share any mentoring tips and strategies, and we'd like to have a discussion finally on what can institutions, mentors, and undergraduates do for initiating research-based practices. So what I have, we've sort of come up with certain questions, and so what I would do is pose the question and maybe call a few panelists who I feel maybe have sort of maybe to start with some discussion on the topic. In order to sort of keep the discussion flowing, I would, of course, move on to a second question. But if anybody in the audience or even the panelists want to add anything or have a question, please feel free to put them in the chat and we will take them at an appropriate place. So without further ado, the first question, which is related to the importance of undergraduate research, is I would like to pose to the panelists and maybe over their career, I mean, how do they see the state of undergraduate research evolving in India over the, let's say, even past decade, or even put their career as they would like. So I would like to maybe ask Jan to start with that question, maybe followed by Dr. Urmila.
Yeah, thanks, Sriram. So in terms of evolution of how undergraduate research is seen in the country, I would say it is kind of becoming more and more important. If I recall our UG days, it was like undergraduate was seen as, after 10th standard, there is 11th standard, after 11th, there is 12th, and then there is 13, 14, 15. That's how UG was kind of seen. However, nowadays UG is kind of treated at a different level than what happens until 12th. So it's super important from the student's perspective to explore what is out there and what is it, what does it mean to actually contribute something to the field. And that also gives a nice feedback to what should they focus in the typical classroom, what is important and what is not, how do they structure their knowledge, experience, skills. I think it's a welcome evolution that there is more and more emphasis on research, and particularly in NEP, there is, I think, all students who kind of complete their 4 years have to go through an internship, which is also a welcome move, I would say.
Thank you, Jan.
Yeah.
Dr. Urmila, please.
Thank you. So, undergraduate research has has so much of importance, and it is now getting deeply rooted in our education ecosystem, as I have seen, over the past 25 to 30 years. The system is gearing up through NEP and other initiatives, as well as, to even the professionals in terms of scientists, researchers, and teachers are also, I think, have gone a long way, and I see a shift in terms of their thinking to have, undergraduate students in the lab and to train them, to nurture them as future scientists. So NEP is going to give a lot of opportunities for undergraduate students to join the labs, have a sneak peek at how research is carried out in universities, central universities, in institutions of eminence, and over the entire ecosystem of education in India. And at the same time, when mentees have a lot of opportunities, I think mentors also have a lot of opportunities to have these young, undergraduates to be inducted in the lab, and then as you say, catch them young and groom them. So not necessary that every mentee who would join a lab would turn out to be a researcher or a scientist or an academician. That's not the goal. Even if we can impart critical thinking, problem-solving approach, rational thinking, to be able to ask questions and to be responsible citizens in whatever they do, I think having them in the lab and investing our time with them would be fulfilled. I hand it over to you and look forward to other, panelists to make their points. Thank you.
Thank you, Dr. Urmila. So I would also request Dr. Kanika and Dr. Lakshmi to chime in, both to the original question which I had posed and the second question which Dr. Urmila partially answered. One is, how do they see the state of undergraduate research evolving in India? And secondly, how would exposure to research benefit both undergraduates and let's say early career researchers who might be coming to India potentially from outside, but even otherwise maybe starting their academic career in India? How is this kind of tapping this potential? How is that useful, or what are the benefits?
So can I go first?
Dr. Sure.
Yeah. So I would actually like to start with an example. It's my favorite example of how undergraduate research benefits both the mentor and the mentees. So I think many people here would have heard about the famous Agrawal-Kayal-Saxena primality tests, which is, without exaggeration, one of the most important discoveries in mathematics of this century. And it was actually an undergraduate project which was undertaken by two students, Nitin Saxena and Neeraj Kayal, under the supervision of Professor Manindra Agrawal at IIT Kanpur. So, and the beauty of this project was, so Professor Agrawal had been working on these types of questions for a long time, but because this time he was training undergraduates, together they came up with very fresh insights, very fresh approach to ideas from a field called sieve methods in number theory. And they solved a very important problem, and the entire mathematical community was stunned and so impressed with what happened. And okay, leaving aside how illustrious the result was, both the mentees went on to have successful careers, and one of them went into academia, the other one went into industry. So it's not as if undergraduate research is only meant to help you become a PhD who will become a professor. There are many routes, and this, as Professor Urmila pointed out, this just trains people to think independently, critically, become responsible citizens, have an awareness of how science is done, and then take it to many different fields. So yeah, I wanted to mention this example. And like I said, not every undergraduate project will be as illustrious, but we have seen, I work at an institute which takes it very seriously. In fact, our students in the final year exclusively work on research projects. So even if a project does not lead to illustrious results, it often gives a student an idea of what goes behind a career in scientific research. So at ICERS, where we have seen that very often the project provides a foundation for PhD topics later and a successful career. So for example, I think the earliest ICERS started in 2006, 2007. And the students who graduated from the earliest batches are now joining as faculty members at various universities and institutions in India. And we have seen that their PhD work was actually motivated by work that they did in their undergraduate projects, and they took it forward. In many cases, students moved out of academia, and it may feel like the undergraduate project did not have an effect on their future career, but not really. I mean, like, they learned how to think independently. The fifth year gave them the time and space to transition into a mature person who can take and own their decisions. And, you know, even if they work in a different field, either industry or in some cases, students have gone into, you know, government service. I think it's amazing that these students had foundations in science, and they will be able to use this awareness to take our country forward as far as science and technology is concerned. So yeah, this is what I wanted to say about the importance of undergraduate mentorship.
Thank you, Dr. Kanika, for the example and the optimism that you have shown. Dr. Lakshmi, if you can add or your thoughts on this issue, that would be great.
Yes, so this session, I feel very strongly is a very important one to discuss, especially in the current scenario where we do see in our undergraduates, when they come from the school to college, there is a huge jump. So in terms of what concepts we are asking them to comprehend, be it subjective, if we could make the whole experience of do it and learn it yourself, which is what research is about, that may be a much more engaging perspective for the student. This I'm saying forth as a student 15-20 years ago, when I've learned I learned by being in the lab. Thankfully, my undergraduate institute gave me that opportunity, and it is the reason I'm sitting here as a scientist come an educator. The additional thing is when it will also, if the students are engaged, if the undergraduates are engaged in a research experience, it gives them, it actually increases their engagement in their undergraduate studies. They will look at concepts much more clearly. It will engage them much more better in their actual quote-unquote academic pursuits. It also would help them give certain practical skills like problem solving, communication, information synthesis, which in the current structured other kind of coursework that they do may not be very useful. But when they're engaging with a mentor, a research mentor, or a teacher who's taking them through the research experience, either as a project-based learning, these skill sets become something that they can gain with much more confidence because they're going to do it themselves. The other thing is exactly what the other panelists have been reiterating. It is whether they're going to be in research consistently, or are they going to go to any other profession, the other alternate career paths, which irrespectively, we're going to broaden the higher skilled personnel that's going to be available for the country. So in that perspective, this undergraduate research becomes very, very important. And I'm just going to highlight, just going to reiterate two things. One is, for the student, when they finish an undergraduate research experience, whether they do it as a last year project, which the current educational system emphasizes, if they can see it not as a paper publishing exercise or a CV enhancing exercise, but more so if we can orient them, we can mentor them to think of it as an exercise to how do you think scientifically. If we can inculcate the scientific methodology in them as mentors, I am sure that they would stand to gain both professionally and personally. This skill set will enhance them for the career. It will also give a very authenticate experience of research, right? So research, like everyone said, it gives them a very early on idea. If they want to go in the field of research, it gives them about what research is, the hardships present in research. It gives them a real life example. They live through it to know what it would be. But even otherwise, in totality, whatever they learn here. So we have our graduates who finish. So as I've only been teaching for 3 years, been a hardcore researcher before that. But even in that, the students who've passed out, they come back and tell us about the skills that they learned in their final projects. And it is never just about the science of it. It's more about, ma'am, in the difficult situation, when we didn't have access, when we didn't get the product, we had to innovate, we had to think on our toes. And that helped me in the interview. And that helped me in securing the job. Ultimately, although we're talking here about research and enhancing research personnel in the country, we also need to address the whole scenario that in our country, the whole percentage of students who are only looking at jobs, post-undergraduate. So it's also these skill sets that they can pick up when they do these questions on their own. Coming to the mentors, the excitement that an undergraduate brings in, the different perspective an undergraduate brings in, and also the inhibition that they don't have to ask a question. They don't have any inhibition to ask a question to you, which your PhD student or a postdoc may not ask. Just because some kind of an authority is established, although it shouldn't be there in a system, but an undergraduate student most likely would not have that inhibition. So they would ask you why you're doing what you're doing. Explaining in simpler terms would help your whole laboratory to understand the science you're doing way better. Also, they they sometimes help you start a new trajectory in lab. It's happened with me. I have a fantastic undergraduate student who's currently in her 3rd year. She has been consistently talking to me about neuroscience. I had never worked on neuroscience. I've worked on signaling networks, but because of her, I engaged with another neurosurgeon, and we're trying to do a project for her. So it piques my interest too. So I'm broadening my perspective in my career, and that also happens. It's a complete give and take mechanism where you can mentor, but the mentees also end up mentoring you of how you go about in your career. So it's a complete give and take engagement.
Thank you, Dr. Lakshmi. So if I may summarize some of the points that have emerged, even though our panelists are from very diverse institutions and very different disciplines, it's very interesting to see some very important common themes emerging in their reflections. First of all, I think both Jayant and Urmila, and I'm sure others, all 4 panelists will agree with this, that the nature and importance of undergraduate research is changing in the country, both because a lot more emphasis is being put on research, but also I guess the imagination of the undergraduate education itself is changing through NEP and other initiatives. Secondly, all 4 pointed out in different ways that it is essentially a mutually beneficial relationship for both the student and the mentor. Students, of course, get, not only real skills in the discipline, but also certain life skills, including critical thinking, thinking on their feet, and so on. And of course, for mentors, they get an opportunity to visit or revisit things that they would not have done, and also maybe see things in a perspective that they would not be able to because it's being viewed by a fresh set of eyes and new individual. So again, very thanks to all 4 panelists for pointing all of these. So I would like to move on to the second topic or the second theme that we wanted to explore. Now that at least we hopefully have made the strong case that undergraduate research is important, I would like to move on to hear from the panelists about certain mentoring strategies, both that they have used and also certain issues that we think might be important in the Indian context. So again, I will go in some order of the four panelists, but the first question is maybe from their own experience, if they can talk about how what are the strategies that they use to initiate undergraduates into research in their particular discipline, or and what kind of, especially how do they sort of try to rope in or promote the undergraduates to take up research problems at an early stage, even though it may not be required, let's say, for their project, for their curriculum. So again, maybe I'll start with Jayant, and then we'll go in the same order.
Yeah, all right. So, so there are few strategies I believe are very beneficial for the project to run. First of all, at undergraduate level, students will be kind of, for the first time, will be exposed to something professional. So along with whatever scientific skills that the project demands, it also demands to a large extent some organizational skills. For example, it requires some good amount of organization in terms of time. It's not like kind of, I mean, for a good professional research, some kind of progress at regular intervals is needed, and it's kind of students should take that seriously, because when mentors invest their time, it should come from students that this project has been taken seriously. So some kind of mentoring on time management is, I think, crucial. And the organization also extends to file management. So I'm a theoretical physicist, so it requires me and my students to write codes and requires them us to check them and so on. And what is most important is to have a clean record of how a particular code evolved, and to maintain backup, and to clearly, there will be like thousands of files generated, and how to organize the particular thing. That itself is a great learning experience as a researcher. And some help that the students will come with some naive ideas of, oh, this is how computer has to happen, and there will be some final dot something, and then there will be super final, mega final files. And at the end of the day, if they want to track something, it will be difficult. I think that is something that we can contribute. And the other point is, as and when some new stuff comes in, it is better if it gets documented and typed out at regular stages. In fact, I would say my students to come up with a thesis format right on day one, and then you keep filling different chapters as you kind of discover more and more, so that there is no loss of continuity at any time, and there is a clean trial of how the project is being developed. And we should encourage students to attend seminars. Typically in all good institutes, there will be some weekly science seminars or something of that sort. And whether it is something that is closely related to what the student is working on, or even if it is remotely related, or if it is completely unrelated, students should be encouraged to attend. And many students at that age say that, okay, I'm not understanding, it's too much beyond my level and so on. And only when students get to attend more and more, they kind of figure out how to get things from a talk, and what to focus, and what are uninteresting details, and what is the main heart of something. And another crucial thing is, as a researcher, one should kind of take responsibility for whatever results one generates. Every time someone may not be monitoring whether what is done is correct, and so on. Oneself has to come up with some some checks to make sure that something is correct and so on. So that responsibility is crucial. But as students, because they are starting for the first time, it is perhaps strategically beneficial if we pretend as if they are given responsibility, but at the same time we are kind of doing some kind of check to make sure they are not producing something, that they are not in the wrong direction. And of course the direction is, of course, that's a very broad aspect. Even with respect to details, it's important that we also kind of parallelly run through, so that they kind of know when they could have corrected, and then they could have made cross checks and so on. And the last point I would like to make is, in certain cases, I have seen students taking a research forward in a way that they follow the instructions given by their mentors, and that is not beneficial to the students at all. So that will kind of train them up, perhaps at the best, as good clerks, I would say. But as scientists, they should be kind of encouraged to ask new questions. Solving a given question once it's a cleanly posed question is kind of routine, and many students get trained for that, and people will do it. And to ask a good creative question is a big challenge. And I think whatever room students get to ask new questions is, I think, a good strategy to help them in getting started. Yeah, thanks.
Thank you. Thank you, Jayant. Yeah. Thank you, Jayant, for wonderfully stating, importance of time management, importance of good laboratory practices, ethics, and, in general, emphasis on producing or sort of inculcating good research practices, and to encourage them to be independent scientists or thinkers rather than just being technicians or the clerks, as you mentioned. So I'll take these points forward and would like to, speak from the perspective of both the mentors as well as mentees. When I started mentoring, what I realized that the most schools do not teach how to mentor. Okay, so they don't give any formal training with respect to how to start a lab, how to build a group, how to build capacity, how to build teams, how to motivate, young students at different levels of their career, or, how to manage resources, how to network and collaborate, how to handle failures, how to mitigate challenges, and, how to plan the outreach on social media, let's say. As you start mentoring, especially when I started, I work in the field of bioinformatics, which is one of the STEM research area, and interdisciplinary research area. We were one of the first, to enter this area when the word bioinformatics or computational biologies were just being heard on the scientific horizon. We learned, there were no books, there were no teachers, but how we learned by reading the research papers, then downloading those algorithms or the programs, compiling them in debuggers, watch how the variables flow, and then back map it onto the research paper to understand or crack the algorithm. And we have had that enormous joy of almost, discovering or rediscovering a lot of scientific methods and databases. And that is how, slowly over the years, I developed, and along with me, I think many of my colleagues have developed, and there will be so many parallels when we say that we try to become mentors. So mentoring, there is no age, and it's not gender dependent. As a PhD student, you can mentor undergrads. As a postdoc, you can mentor undergrad and PhD student. As a scientist, you have, the whole hierarchy down the line to mentor, and then it is very important, I feel, based on my experience of 25 to 30 years, that it's very important to set the goals and expectations right when you accept a student for mentoring. Okay, it is also very important to normalize free and open discussion between mentors and mentees. I think in Indian culture there is this aspect of respect, and out of respect, students, the way they are trained through the school system, hesitate to ask questions. But first thing that we have to undo when students come to universities is to tell them it is great to ask questions. Please ask questions. No question is a silly question. And when they ask questions, the mentees ask the question, mentors also, grow. They learn to answer questions coming from different students, different perspective, different disciplines, and so on and so forth. It is also very important for mentors to establish a very comfortable, inclusive environment with mutual respect and trust, because only when you do so, they will grow to have that as a foundational values, and then that is passed on to next generation. So there is no need. I feel one of the aspects that we in Indian academia need to worry about, there is no need to feel insecure at any point of time in your career, and you have to just assure n number of times to your mentees, to your colleagues, that there is an equal opportunity for all of us to grow. We perform as a group, we grow as a group. There is no competition. I'm sure all of you might have heard those stories of cockroaches pulling each other's down, and things like, or crabs pulling each other down. I think gone are those days. All of us understand importance of importance of teamwork, and I think if we want a radical shift in Indian academia, we have to establish this trust, mutual trust, and help our younger generation feel very secure. As mentees, I think for us, every student should matter. They come from different backgrounds. And I feel, at least what I have done so far, that I look at the strength of the student rather than identifying, his or her weaknesses. So you appreciate, you help the student charter a growth plan on the basis of his or her strength, and you slowly keep supplementing so that they overcome some of the limitations or some of the problems that they need to work on. So, and without having them felt that you are working on them to sort of, you're trying to help them improve or something like that. I think it should happen very naturally and organically in the lab. And once you set the culture of the lab, I think it just passes on from generation to generation. And Jayanta has very beautifully mentioned importance of obstacles and how you address them to build this supportive ecosystem. We also need to pay attention to physical and mental health of our mentees, and most important, tell them that they should enjoy life, they should enjoy working in the labs, because unless and until they derive sheer joy, I don't think they will be imbibing or inculcating this passion for science and passion for discovery discovery. From the mentee's point of view, if you allow me to speak for a couple of minutes, I would like to state that we have to I don't say it's not that we are going to preach and help them develop certain skill set, but we have to, very, very softly in the background, help them develop certain skill set to survive in academia, to survive in industry, or survive in this world, and to be able to ask relevant questions to solve some of the critical problems. So, you have to entrust upon empathy, be empathetic towards them, be compassionate. You need to appreciate them a lot. I think people perform better on appreciation than on, pointing out faults or sort of, telling them you did not do this right. You have to watch out for your tone, your language, especially when you are dealing with young children. They shouldn't be hurt in any fashion. And then I feel that we as mentors need to also pay attention to the diversity and inclusivity. We should be open with respect to these two aspects, and mental health of students. I think there should be a transparent, continuous communication between the lab members, with mentors, between the mentors and mentees, and I think that would help them grow. And one last point I want to emphasize is importance of communication. What I have observed over the years in university, that our students hesitate to ask questions, they hesitate to write, come up with the drafts. So importance of communication, right from how to write emails to how to email etiquettes, to how to come up with drafts, how to modify the drafts, why you shouldn't be stuck with the first draft that you have ever written, and why papers or theses undergo several revisions and versioning. They need to understand that. They also need to understand, and we need to sort of prepare them, preempt them, that they should be prepared for rejections. And when a paper get rejected, let us say for a young undergraduate or PhD student, or for that matter to a colleague, so it's paper that is rejected. Don't take it personally. If sometimes when kids are young and we sort of no matter how much in a healthy fashion you try to point out certain limitations, they don't see that we are discussing with respect to their work and their ability to work, so they take it personally. So I think that is another aspect we as a mentor need to deal with young mentees. And also allow them to ask questions, them criticize you, and that would make I feel an impactful ecosystem where both mentees and mentors would thrive and progress. So over to you.
Thank you, Dr. Urmila. Since Jayant mentioned time management, I have been informed we have around 30 minutes left. So we'll try to be a little bit more mindful maybe of the time. But I also wanted to take this opportunity to introduce our fifth speaker who just joined, panelist, Dr. Shiba Vasu. She's from a neuroscientist who works in CSR, and for the purpose, from the perspective of this panel, she has been involved with the project project-oriented biology education at JNC.
Can you hear me clearly? Very, very sorry to everyone that I joined so late. Please accept my apologies. I got stuck with something and I suddenly remembered that I was supposed to be in this meeting. Very sorry.
Yeah.
I thought maybe, I'm not sure who are the other people who are listening. I thought since I have been involved in these fellowship programs for undergraduate students, I thought my role would be to inform the audience about such possibilities if there are young PIs who have just joined and are not aware of these. So the Jawaharlal Nehru Center has been offering summer fellowships to undergraduates for a long time, very long time. Even as a undergraduate myself, it's probably the flagship program of the center, and also it is probably the earliest in this country. So these fellowships are basically meant for BSc students and also for first year MSc students. They apply very early, like as early as October or November, and then the applications get screened, and they are allotted mentors all over the country. So what usually happens is that us biology faculty members or physics and chemistry faculty members sit and look at these applications, and knowing other people who are studying, who are doing physics or chemistry or biology research, we allot students that have been selected to these various people. It's mostly by people we know or whose website we are familiar with and so on. But young PIs often we don't know because they're not in our network. So it's a good idea for these young PIs to look out for such fellowships. JNCSR fellowship is only one. Besides that, there is this tri-academy fellowships. So previously, each of the Indian academies were offered, so there are 3 of them, and each of them would offer summer fellowships, but now they've all come together to form this tri-academy fellowships that is mainly run by the Indian Academy of Science in Bangalore. And they offer a very large number of undergraduate fellowships, and they make it a point when they select applicants to not only match their subject interest, but also try to put them in a city that's not their own. So the idea is you're not, staying at home and going to this lab and coming, but you actually are forced to go to another city in another part of the country. So it's not only about learning in the lab, but also getting the chance to, now be out of your home and be involved in research in a much more immersive way. So besides that, also the TIFR has summer fellowships. So I think this is something that young PIs may not know, and it's a good idea for them to look out for. And also to reach out to these organizations, for example, the academy, and register themselves as being willing to mentor undergraduate students. And also, in fact, there are programs for mentoring or offering mentorship to college teachers who are also always looking out for such opportunities. So these 2 things are available. I don't know if there's anything else, because I know you all have discussed a lot. So in terms of information, I thought this is a good thing to pass on.
Thank you, Dr. Vasu. So we were discussing certain tips and strategies that mentors will follow for their mentoring undergraduates in their labs or groups. So, but maybe what I would like to add is we've heard from Jayant and Dr. Urmila about certain things that they have done, but it may also, our audience might also like to know some of the challenges that our mentors might encounter and how they have addressed, including maybe language issues. Not everybody is proficient in English, and how do mentors how have they addressed these challenges? So maybe I will ask Dr. Kaninika to go first, and then Dr. Lakshmi, and maybe Dr. Vasu can go after that.
Yeah, so firstly, I think Jayant and Urmila both summarized really nicely several mentoring tips, and I guess the main things were about being organized and being very patient and encouraging. And so this brings us to the kind of challenges that mentors face. So to address the first one that you talked about, language issues, I think what you really need here is lots and lots and lots of patience, because it's not the student's fault that they are not so comfortable with the language. And if you are particularly encouraging them to give regular talks or keep documenting their work, then the one thing that you have to do on a regular basis is take whatever they are writing, go line by line, point out corrections to them. And my experience has been that in the first 2 weeks, it's a laborious task because you have to keep pointing out lots of errors, but students also pick up quickly. They are very eager to learn. And then as time passes, the frequency of mistakes reduces, and it becomes an enhancing experience for both the student and the mentor. The other challenge that I faced actually particularly pertains to the last 2 years. So all the students, as of March 2020, all students went home, and many of them were like taking online classes for the first time. It was causing them burnout. In addition, they wanted to learn something extra in the summer. Project students had to finish their projects. In many cases, I felt that some of my students were actually mentally affected by just having to be in a room and not really being able to go out. It was really affecting their mental health, because there were students when they started out with me at ICER in 2019, when they were in their third year, they were extremely eager. They had lots of questions, lots of insights. And during the pandemic, I noticed that they would just be quiet. I would be doing most of the talking. So I controlled my urge to become impatient or judge them for it, because it was it's one of the most difficult situations that we have all collectively gone through. And so I took the lead there. That I thought, okay, if they are finding it difficult to catch up, let me just keep doing what I can. So either on the board or on my notebook, I would just keep showing them calculations, and they caught on gradually. And one of them was doing his master's project with me, and he did very nice things towards the end of his program. So yeah, that is the other challenge I thought I'll mention. This is what the challenges that the pandemic brought us. Yeah.
Thank you, Dr. Kanika. Dr. Lakshmi.
So Dr. Jayan, Dr. Urmila, and Dr. Kanika have actually covered most of the aspects of it. So I'll just add 2 cents to it with what I have tried to do to engage the students or to even interest them in the research perspective. The one thing I do is whenever I take a course for an undergraduate course, then either at the tail end or the middle of the course, I would ask them to choose topics that interested them. Instead of giving them the topics to talk on, I'll ask them to choose the topics that interested them and ask them to present something, either what they read in the newspaper, or, so for example, when COVID happened, if there was a course on instrumentation, then I asked them to pick out all the latest innovations that happened and is reported in the news. And then you will discuss that in the class. How do they approach it? And that brought out even students who would not speak generally or ask questions in class. And then they would come and talk to you later. And when even you don't need to tell them that the hackathon is happening. They would come and say, "Ma'am, there's a hackathon happening. Do you think, can I go with this idea and apply?" So the small things of engaging them in conversation in class, taking real life examples, making them suggest real life examples, and then proceeding with it has helped me. Otherwise, so I teach core biomedical students. So when I teach physics, they usually shut out. But if I do this, then they'll ask questions. And then with the class, then they would understand it also better. So what I've learned from the undergraduate is, if they like, if you allow them to choose what they like in your spectrum of what you're working on, if you discuss with them what all is your area of interest, and you allow them to read on it a bit and develop what question they can ask, they respond well. Instead of saying, "This is your project, you should do from this to start to end," that has a lot of resistance. But if you allow them to open out a little bit and gradually help them form the question that they have to test, they have given phenomenal initial observations for the lab. So that's one thing I would actually say. You facilitate for them to initiate the questions, and just be around to help them think in direction and help and tell them you're available. Sometimes they get lost because of the volume of what they have to read maybe. So you structure it for them and keep a regular meeting time. Every week, meet them at consistently the same time, monitor the progress, give them feedback. In this case, I would agree with Dr. Sinha. the language barrier, what I do is I try to tell them, if it's a scientific concept for them to present, I would tell them, do it in your native language to me. Whatever pitch you want to give, you do it in your native language to me. We will then deal with writing it in English or presenting it in English. Initially, you understand the concept and you present it to me in your language, so that you let me at least understand, or you'll have the freedom to present it completely to your ability. And every week, when we give them the short assignments of what they read, what they interpret it, if they can write it and send it to you, if you can just do a little bit of hand holding in initial time for the communication, point them out to places where they can learn from for the communication, they do wonders. They really want to learn. When they've come to you, they sustainably send you those write-ups, means they want to change. They want to learn in that direction. And if we are patient, then they respond quite well. And COVID, as Dr. Sinha said, has been a major problem in their thing, and exactly what she said. We have to be patient with them. We should understand we ourselves at our age are undergoing a lot of paradigm shifts. For them, this has been, we've taken away the joy of college from them. The COVID has removed the joy of college, meeting friends, speaking on the peer group is completely lost. So a bit patience with them. It will take a while to come out of it. So if you can be patient and constantly boosting their morale, engage with them in a way like a parent would do, in terms of being there for them. If you can build that rapport, they respond quite well. Thank you.
Yeah, thank you, Dr. Lakshmi. Dr. Shiva, if you can add anything to this discussion, but there's also a question asked by one of the audience members, which is specific for JNCSR, and I don't know if it's factually correct, that the question is that during the pandemic, the POP program has not been conducted. Can this be done online, or are there any plans to conduct online?
Maybe my internet is unstable, so I'll turn my video off and I'll continue speaking. Okay, check. Okay, so check. You can hear me, right? Check.
Yes, we can.
Okay, yes. So indeed, that was correct. In fact, we went through the screening of applications for both POBE as well as summer research fellowships. But when the pandemic struck, there was no way we could conduct it, because POBE means having students. So the POBE program, just so everyone knows, it's different from the summer research fellowships. Here, students only up to 8 to 10 students are selected when they are in their first year of bachelor's, and then they come first summer, second summer, third summer. So they spend 3 summers at JNCSR, at the end of which they get a diploma. So that's how this program is structured. Now that means that students have to come and stay on campus. With our own students not being allowed on campus, it was just impossible for us to conduct it on site. Nevertheless, what the program coordinators did was, they said that those who have been selected and are now in second and third years, they can engage online with their mentors. So that's how it was told to all the students. Talk to your mentors. Mentors will guide you through some maybe reading project or some kind of online interactions. Sometimes some people even did some computational work and so on. The same thing happened even in my own group. This year, I was just told by our dean that they are planning to set off, even though it's pretty late, because we usually by this time already have selected and our lists are all final. But now we are in fact going to initiate the program. So this is what I was told verbally. An official communication has not yet come. But the expectation is that we will start again, and this year hopefully still be able to hold the summer programs.
Thank you. So in the interest of time, I will move on to our third theme, which was about what can institutions, mentors, and undergraduates do. But I would just pose one question, and one which we wanted to also hear from the panelists. So I'll combine both and maybe panelists can give their views. So the question I have is, in a way, given the way the REACT has been thought of, which is the undergraduate mentorship program that we hope to start as a way of democratizing access to research opportunities. Our question is, how can we involve more undergraduates from underrepresented students or underrepresented universities or universities which don't necessarily have facilities. Even though the students may be curious and capable, but they just don't have the opportunity. How can we expand that kind of opportunity? And any advice that they would like, given their experience for the program before we start in earnest in soon. So I'll pick a different order. Maybe Dr. Karinika Sinha, you can start first, and then
Sriram. So actually, I was thinking, 2 decades ago when I was a student, the idea of doing workshops or summer programs for students, just learning programs, that itself was new. So at that time, programs like MTTS and Tata Institute's Visiting Student Program, they all started. And I think it's amazing that now that we are catching on to undergraduate research in a big way, the REACT program is trying to do something similar, but with a much bigger goal of undergraduate mentorship. So I congratulate you for this idea. I think the main challenge would be to select the students who would benefit most from it, right? So for example, students who are at ICERs, some of the central universities, etc., already have access to facilities and trainings in undergraduate mentorship. The idea is to get students from colleges which don't provide them this facility. And I suppose the main challenge would be for the organizers to select students. In our time, as a college student, when I started applying to summer schools, my professors at college did not even know how to write recommendation letters, which were required for our application. So they would just say things like, oh, you write yourself, I will just sign. And I suspect that this again might happen, so I'm sorry, I'm not really offering any solutions, but I think this might be a big challenge you would face, and it would be great if other panelists can suggest how to overcome this.
Yeah, I think that I see 2 hands raised. Maybe Anushila, you can answer first, and then.
I just wanted to take up Dr. Sinha's point, is that we actually thought about this barriers that, a lot of the students were coming from tier 2 or 3 universities might not have mentors who write them the correct recommendation letters that they deserve, or we might end up selecting students like the wrong students, basically. So we don't have a requirement for recommendation letters. We have specific questions that are trying to gauge their interest in their scientific temper mostly, and their understanding of if they're curious or investigating.
Thank you. Dr. Shiva, you had your hand raised, so I don't know if you wanted to
so
add
first,
something.
I thought, because we've been doing this screening of these forms for so many years, and over the years, sadly, we get like 300, 400 applications for a really small handful of awards that are given out. So it is really a big challenge. And our biology faculty, we are sometimes, there are 12 of us, sometimes, about 8 or 10 eventually manage to get on that day to meet and screen through these applications. And unfortunately, we do this thing about sorting them first by just marks. So of course, before that, what we do is we divide them by geography. So there's this north, south, east, west. And we know that typically the south, there's the largest. So you'll see the largest bundle is from the south and the west. Okay. And there are smaller numbers in the, south and north, east and west, the numbers are usually small. And even when they are there, we know certain places where all those applications will come from. So we factor in the fact that there are these huge numbers, when we divide up the fellowships, we make sure that we pick those geographical areas that are typically not so well represented and ensure that we have only a small fraction from places which anyway have possibilities to do research like the ICERs. In fact, even though we really like the ICER students, we make it a point not to pick too many ICER applicants to these programs, simply because we would like to have other people who would not otherwise have this opportunity to be able to get these fellowships. So I think other programs, people who run such programs also will come up with these kind of measures, because over time they will see these are the kind of patterns that show up, and in order to be more equitable in our distributions, we will have to adopt these kind of strategies. The other thing is, like Anushila just said, we also have these write-ups, questions about interest and so on. We also have the recommendations from teachers. Even though there are all these other issues with these recommendation letters, it's useful to still keep those letters, I feel, because what will often happen is you will have this bunch of 10 students applying from the same college, okay? And then everyone's write-up, sometimes it's a little difficult. So then the teacher's inputs actually come in handy. We often also have this one line at the bottom for the teacher or the referee to say that if you are recommending more than one student, please put your rank order. I think those are all useful things to keep in mind. Thank you.
Thank you. Dr. Lakshmi, this will be the last question we'll discuss as panelists. So maybe your thoughts on how to expand opportunities for research and any advice for the REACT program.
So adding on to whatever they've said, the other additional thing is, in some cases, I should say, there may be a privileged candidate whose area of interest or even brief idea would be given by the teacher, and that would happen. So factoring in exactly how Dr. Sheba said, factoring in where the application coming from, the social economic scenario of it, their exposure so far, those, if you can implement, then I think your reach would be better. Is just, that's, I don't know how you're going to achieve it, but so there is the program of the KVPY, there is the IAS Summer Research Fellowship, there's IIT's Summer Research Fellowship, you have JNCSR Summer Research Fellowship. All of this, the number of undergraduates we have and the programs that are existing definitely don't match, right? But because your UGC is insisting that you have a 6-month project, most of them, if they have active researchers in their universities, they would get exposed to some kind of research or otherwise. The problem would come, exactly what Dr. Sinha said, in colleges which are not affiliated to bigger universities, which don't have a mandatory to maintain a NIRF rating, for example. So you will not have an active researcher sitting over there. Though, not to take away the teacher's ability to build a research question, but if picking up, just to give the student an exposure to how active research labs work, how do they do, choosing from those colleges and those places might be useful. So all I'm saying is add in a factor of where the application is coming from to a slightly larger detail. That's, and you could always have not just a write-up. If you can catch, you're trying to catch them young, which is exactly what KVPY does. They do it at the first year of when they join in. So a generalized test would be helpful, but the magnitude of writing the test may be difficult, conducting the test may be difficult. But just the questions in KVPY were interesting, even 25 years back. It was nothing to do with factual. It was to just think and write. So that would bring out the capacity of a student. And for all you know, from the rural sector, we might get much brilliant brains who are able to deal with the day-to-day scenario, give a solution for a day-to-day scenario. Just think about it also much better. So that would be my 2 cents.
Thank you. I'd request Jayant to add in his closing comments or thoughts.
Yes. So quickly, commenting on what institutions can do to inculcate research-based practices. I think one thing I would say is institutions which run undergraduate programs should invite as much researchers from diverse fields to come and talk to students, and not just talk to students. I mean, like not give a talk, 1 hour talk or whatever, but to kind of have interactions with students for a longer duration, where students can approach them, get to know better what exactly happens in their labs, and get an exposure. And if it's a residential program, if these resource persons can stay overnight, that will actually lead to a better interaction with the student researcher interaction. And in terms of what undergraduate students can do to promote their own projects, is to, as other panelists have mentioned, to do any project out of passion, out of joy, and not because of parental pressure or peer pressure. That's all I would like to say.
Thanks, Chand. Dr. Urmila, if you can share your closing thoughts.
Thank you. So, first and foremost, React is a very, very brilliant initiative. And, when you pose this question of how to, sort of select students, or how to do this fitment of mentors and mentees, what I could think of, is two-pronged approach. One is you have some kind of methodology which you might evolve, or the panelists have suggested to shortlist the candidates and have them attached to the researchers and the laboratories. But then React can also think of another approach, that React ambassadors can go and visit rural areas especially, and can have sessions, half-a-day sessions in different colleges or schools, wherein they go, they tell their research stories, and they sort of enthuse the interest, and let the students speak in terms of what they would like to do, and if that kind of mentorship is also provided, it would be a good idea. Then pandemic has also taught us how to think beyond the normal, and then you can have this virtual internships, although a lot has been said about that the virtual education is taxing, tiring, and there are certain issues with that. But no matter, it also proved that despite the challenges of lockdown, the training programs world over ran with more or less efficiency. So you can have say 3 types of interactions. One is one-on-one, another is online, and the third is React ambassadors visiting the schools and colleges to encourage students to align with the objectives of the React. I think I can think of these as practical solutions to how React program can be shaped. And I'm aware that whatever we discussed is not enough to charter a program of this scale, and many more inputs are required. You can think of, expert database, the mentors database, their areas, and wish list of mentees, and that can be used, to tag the mentor and mentees for some one-on-one interactions or things like that. So offhand, I think I can give you these suggestions. But I think science is a continuum of ideas, and all of us love to sort of start with ideas and then try to address the problems, and that opens new areas, and it's a continuum. And if we can give exposure to young minds with respect to science as a continuum, and science can be done in a very elegant, artistic and happy manner, I think REACT would have achieved its objective. Thank you.
Thank you very much. On this note, I would like to thank all panelists, all 5 panelists who came quite late on a Saturday evening to talk to our audience members. So once again, thank you all. Thanks all of you. And even though I would not call myself an early career researcher anymore, but even I learned quite a bit by listening to the panelists. I'm sure our audience would have found it equally useful. So with that, I will hand over the reins to Manali for closing thoughts.
Thank you so much, Shriram, Anushila, and Shiva for moderating this session so nicely. And of course, our panelists. This was really useful. And I think I was just, thinking that with all your input on how we can take forward the REACT program, can definitely let it run for, 10 more years or so. We were just thinking like maybe 1 year, we will see how it goes, but such brilliant ideas. We can plan for, much more. So thank you. With that, this was the final session for Sci-ROI India virtual launch event. So I'd like to present a few concluding remarks. I have learned so much over these last 2 days, thanks to all our panelists, our moderators, our volunteers, the whole leadership team, and especially our audience. Thank you for joining us. And, I had a few takeaways. I hope you had yours too. But just to kind of summarize, we had such diverse sessions, like starting from, we had really established forerunners in Indian STEM, talking about what young STEM professionals can do when they start their positions. And they had such lovely, inspirational thoughts, don't think about, what can science do for you, like think about what can you do for science and how can you contribute. And, always think about like where your interest is, right? And what excites you. And academia is not really the end of line. There is so much beyond academia that's happening even in India now. So really go for, those questions and aim high and, go for big cutting edge questions and don't, get entangled into small, things that people usually happen to do. Then we had like a session on cross-sector collaboration where I think we had panelists from academia, industry, startup, and funding agency. And, what they told us, just to summarize, our moderator who put it brilliantly is like for collaborations, there's these 5 Ps that are very important, right? So planning for the idea, having realistic expectations, and really you need to have a lot of patience, perseverance for the collaboration, and file a patent as soon as possible for the product you're developing, and have a well-researched and much needed product, right? So just to start, and then there were also discussions about how tech transfer offices are so important to initiate and sustain such collaborations, as well as documentation for IP and patent management. So these are things that we were looking forward to, right? So to know more about where these gaps exist and how Sci-ROI India can help in initiating some solutions for these. So again, like we followed that up with a session on early career grants in India, and there's a lot that was discussed. I just in here and there I just took a few points here, but for grant proposals, again the same point was made that your research idea should be unique, should deviate from your PhD and postdoc work. Be realistic, think about the Indian STEM ecosystem when you're writing your proposal, and do find collaborators and mentors early for your proposal, because I think all the funding and everything is now kind of going towards collaborative, if you work with multi-PI grants and everything. So that's what we were kind of discussing yesterday. And then this morning, the first session of this evening was with, for returning Indian diaspora. And a few of the advices that were given were like, start networking early, even 1-2 years before you are coming back to India. And scope your institutes before joining. If you have a chance to travel, attend conferences, learn about the regulatory clearances that are needed, and make informed decisions. I mean, coming back is a great decision if that's what you would like, but do research, do talk to your peers and mentors before coming back so you know what you're getting into, right? And with that, our final session for today, and again, so many things discussed. I just jotted down a very few points, very few. So, I think something that really struck me was like, we keep talking about research mentorship, but that's really not only for someone going into bench research, right? Like, as we call it, like, it will also give the undergrads or mentees a possibility to enhance their soft and transferable skills and build their thinking capability. And then again, for the mentors as well, our young investigators or PhDs and postdocs, undergrads themselves and mentees provide opportunities to broaden perspective. I think I loved when Dr. Lakshmi said, like, we learn from each other, right? So mentees, mentors also learn from mentees as well. So that's like a very beautiful way of putting it. And then, yeah, I do agree, ask questions. Both mentees and mentors learn, something which I wasn't, taught when I grew up. So I think this is really, really important. I wish, we were also brought up in that kind of culture. So I really encourage everyone, especially mentees listening in, do ask questions. So with this, I'm just going to again put out like some of the programs that we are starting this year in 2022. We will be doing regular webinars on evolving trends in Indian STEM. We already started last year, but we'll be continuing, so people can get to know what's really happening, what's the new and exciting thing that's happening in India. Then we talked about React a lot in this session. So keep an eye out. We are planning to start the first batch in summer of this year. So, everyone who has registered will definitely get to know more about this. We also talked about a collaborative database that we have started. So, any independent Indian STEM investigator or researcher, can add themselves to the collaborative database, and that will give them opportunities, to initiate collaborations. We are also thinking along the line of collaborative database to start some tech transfer courses. Again, as we were saying, these are the offices that are becoming really important to build products through academia, industry, research collaborations. So something that we have found is a need, on a national level, if we can have some of these kind of courses. And the last but not the least, we have a lot of interest in, brain circulation as well. So we are looking into how to bring back Indian diaspora, so they can come back and establish themselves in India as well. So we will have a personalized return to India mentorship program for them. So, their transition can go smoothly and they are highly successfully established when they come back. So with that, thank you everyone for joining again. Please become a member if you feel these programs will benefit you. And if you have any suggestions for us on how to improve or, to implement other programs as well, we'll be happy to hear more. So do write back to us. And we are also on the social media platforms. Just search for Sci-ROI India and you can connect there as well, and we'll be updating our, whatever we are doing, we'll be updating there as well. So with this, I would like to invite Professor Aseem Ansari. He's the founder of Sci-ROI India, and I just wanted to maybe hear a little bit about, and nothing of this would have been possible without his visionary approach. So just wanted to know a bit more about this from your scene. So.
Thank you, Manali. I mean, it's humbling to see where Sci-ROI has come. I want to thank all the panelists here. I want to thank all the volunteers and the leadership of Sci-ROI over the years. So, you've heard a lot of things today. And what I took away was actually inspiring to me after 50 years of being here. A lot of things, a lot of messages that are relevant no matter where you are, whether you're in India or here, anywhere. Patience, persistence, perseverance, these things are absolutely important. These are things that came up recurringly. Thinking out of the box, not imagining yourself within the parameters that the world has drawn for you. Here's your academic path, here's your industry path, here's your family path if you're a woman, right? This came up quite prominently yesterday, where the challenges faced by women, societal, biological, and then the lack of empathy or realization that these are real challenges. You can't just sweep under the rug and pretend they don't exist. All these things are learnings for me as well. So how do you work with these parameters and imagine solutions that are non-obvious, right? This can only be done if you're looking for solutions. Often we are simply complaining about the problems that we see, right? And what Sci-ROI has embodied for me actually is a continuous search for solutions. Now, somewhere in the questions, I think Piyush put down that, Sriram came to me when we were planning for the Khurana program. And part of the Khurana program, again, one of you here mentioned TIFR summer programs. I'm a product of one of those summer programs. Many, many, many years ago. I won't tell you how many. But I accidentally loitered into a summer program. I experienced the joy of discovery, and that completely changed my trajectory. I was going to go do something completely different, right? And I wanted to share that with other undergraduates at that formative point in their career, second year, third year summer. And I remember when KVPY came to life, with Dipankar, we were actively involved in building KVPY ICERs with Ganesh. I remember that with Sienna Rao and Ganesh sitting in those meetings. And Khurana program came to life at the same time. Khurana, KVPY, ICERs, all of this, Dipankar at ISC, Ganesh at Pune, NCL at the time, and myself out here at Wisconsin. All of this was to enable undergraduates because all of us had experienced a moment in time where, the joy for discovery became apparent to us, right? So that's where we were. And then, of course, Sriram came along. He was a postdoc or a scientist at the Wisconsin Institute of Discovery and said, well, what do you do for people who are looking for career opportunities in India? And that struck a chord because I had classmates who had done their PhD. I'm sorry, I should just pass this down. This is just basically waving. Classmates who had, finished their PhDs and couldn't find career options, right? And they got stuck in these intermediate career paths where they were neither assistant professors or independent investigators, nor were they postdocs, right? They're stuck in these like subordinate positions, and their brilliance is used by people who are above them. And so I tried to encourage many of the postdocs in my lab, have you considered going back to India? And I had failed consistently. And part of it was because I didn't know what opportunities existed in India. And so Sriram provided that critical, nudge, if you will, and then his energy and his enthusiasm and his organizational skills were absolutely critical. In a matter of a few months, it was exactly 7 years ago. I remember it was February or March of 2015. We were trying to organize the Khurana program's orientation for May. And Sriram sort of brought this question up. Then he came to the meetings we were having for the orientation. And very quickly, he reached out and assembled a group of people who came to the orientation of the Khurana program at the consulate in Chicago. And Sci-ROI was born. Sci-ROI was then, of course, propagated by a continuum of leaders. Somashish was one of them. Piyush is there. Now you have Manali. And then you also have Anushila, you have Siva. These are volunteers who decided not just to passively listen, oh, here are the opportunities. But when they found a gap, right, something they wanted to know about and wasn't being done, they stepped in and said, why is this problem still here? This is what goes back to think beyond this problem, think about the solution, and not just a solution that is impractical, but an implementable, small, simple solutions that can make a big difference. And there are many. We all look to, I have this rare disease, how I'm going to cure it. There are many ways, many steps on the way that we sort of leapfrog almost, because that's what we are taught to do. But in this case, to make real change, you have to do that. As we started sending people back, and all these volunteers found new programs, tech transfer, innovation, entrepreneurship, etc. Not just academia, IITs, then ICERs, then, why not look at private universities? And you heard Somashish talk, you saw Piyush, etc., have gone to private universities and are doing really well, right? If you'd asked me in 2015, would you send a talented person to a private university? I would have said no. Today, I've completely changed my mind, seeing what private universities are trying to do for the scientific ecosystem discovery and education in that sense by doing. So things are evolving, volunteers are making it happen, and I wanted to thank that and acknowledge that. Right? And so why Sci-ROI India today, right? Sci-ROI India similarly came about when I was visiting India in 2016, 17, 18 it was, where a group of people that had gone back had taken up on our challenge that go back to India and be change agents, and they had gone back and they were encountering serious bureaucratic problems or just ecosystem problems where people didn't know what to do with people at this level, because a junior assistant professor in India is an assistant to the professor, right? They're not independent investigators. The head of department says, teach, go get the guest, organize this conference, take care of my laundry, all they will do, right? And so how do you change that ecosystem, especially if you're not even a lecturer or reader? It's even worse. If you're a fellow, they don't even know what to do with you then, right? So recognizing this over those visits back to India for the Corona program, for Sci-ROI, etc., for various things, what became clear to us, and I remember Arun poignantly pointing out, and a couple of them actually came back to the US, right? People who had gone to really, premier places, not small places, premier places, encountered serious challenges and decided to just come back. So having seen that, they motivated this idea. And I remember discussing this with my partner in crime, Navida. And she said, what we really need is a network in India that supports people who have made that difficult decision to go back and build their careers and be change agents in India. We need to give them voice. And that's how Sci-ROI India started. And it was November 2019 when I was last there. And I met with some of the policymakers, and they were talking about STIP at the time at the PMO's office and DST, DBT. All these guys were at the India Science Fair in Kolkata. And there was a lot of interest, and the minister was there. And he said, well, what we should do is build Sci-ROI India. And there were many Sci-ROI alums who showed up in Kolkata. And that group then, at that point, nucleated the thought that there should be Sci-ROI India. COVID hit, and that slowed things down. But as you can see, this launch has made clear that there was need, there's opportunity, and the impact you will see for decades, right? React, all these programs that have emerged are brainchilds or brainchildren, if you will, of people that have gone back, people who are here, who are thinking of ways, non-linear ways of impacting the ecosystem and bringing about change in a mutually beneficial way, not just some charity being done. It will benefit the entire world. It'll benefit us, it'll benefit people there. So my last piece for the 5 people who are left at this hour, beyond the panelists, is that if you've stayed this long, you clearly want to see a difference, make a difference. Join this organization, work with the volunteers, bring your ideas, and let them help you to either integrate your ideas or create things that address problems, create solutions, refine your solutions and implement them. And be the change agents that you are inevitably going to be one way or the other. Come in, join, and make a difference. And with that, once again, let me thank everybody at the panel, people who have spoken in previous panels. They've inspired me. Every year I go through this moment, it's like, should we do this? And every year when I hear these sorts of things, it is the energy bolus I need to continue. So thank you very much for that. And Manali, Sriram, and the panelists, Siva and Anushri, of course, Anushila, sorry. Thank you for moderating this amazing panel today. I really loved what you're putting together, and for the entire session, and for launching Sci-ROI India. I hope all the panelists will help us build Sci-ROI India. It is not a copy of what already exists, like India Biosciences or other things like this. This is for all sciences, and it's at multiple levels. It's not to just present your best work, but also present your problems, explore solutions, and make a difference. Thank you very, very much. It's been an honor and just an inspirational experience for me.
Thank you so much, Aseem. This was a really nice, ending to our launch event, and we hope to continue this journey in the coming years. And thank you, our panelists. It's pretty late in India and you are still staying back. So thank you so much, and our attendees as well. With this, we'd like to finish this session. Thank you for joining, and we hope we can stay in touch and collaborate in the near future. Thank you so much, everyone.